Welcome to the Techno News Channel, and in today's issue, you are waiting for IBM unleashes the world's most powerful quantum processor. German Bionic debuts its lightest powered exosuit. Thales Alenia Space studying reusable spacecraft for in-orbit manufacturing. AI-driven combat drone. Black Hawk helicopter flies autonomous rescue mission without crew. DARPA and NASA plan orbital nuclear rocket test. And Perseverance drops first sample tube for potential return to Earth. So let's go. IBM has unveiled the Eagle, the world's most powerful quantum processor. Boasting 127 quantum bits, qubits, the Eagle is a major step towards commercial quantum computers outperforming traditional machines. Quantum computers take advantage of the quirky world of quantum physics to boost computing power to incredible new heights. In a classical computer, data is stored and processed in bits, represented by either a 0 or a 1. But in quantum computers, qubits can not only be in a 0 or a 1 state, but a superposition of both at the same time. That means that each added qubit raises the potential processing power exponentially. At 127 qubits, the Eagle is the most powerful quantum processor in the world right now, far surpassing China's 113-qubit Zhejiang 2, Google's 72-qubit Bristlecone, and IBM's own 65-qubit Hummingbird processor. IBM says that the breakthrough was made possible by a new chip architecture that crams more qubits in. The qubits themselves are arranged on a single layer, which reduces their error rates, while the control wiring is spread out over several physical levels. German Bionic, the robotic exoskeleton startup behind the Cray X, will be showing off two new posture-protecting products at the Consumer Electronics Show in Las Vegas, Nevada this week. The Apogee is the company's latest and lightest powered exosuit built for commercial and industrial use, while the Smart Safety Vest will bring ergonomic monitoring and protection to every worker, per a Monday release. The Apogee builds from the lessons learned in developing the Cray X, resulting in German Bionic's lightest exosuit to date. Despite the lightness, it can offset up to 66 pounds of load to the user's lower back for lifting motion and offers active walking assistance to reduce fatigue. The Safety Vest, on the other hand, doesn't actively help the user pick up heavy stuff, but it does monitor their movements and body positioning as they work and offers data-based, personalized ergonomic insights, as well as assessments and recommended actions. Both the Apogee and Safety Vest rely on the German Bionic I/O architecture to collect, monitor, analyze and report the user's ergonomic data back to them. This is done typically either through the onboard display or via audible alerts when the user is actively making unsafe movements. Thales Alenia Space and Space Cargo Unlimited have announced the signing of the first phase contract for the conception and production of REV-1, the first floating space factory, and the opening of a Space Cargo Unlimited subsidiary in Turin. As project contractor, Thales Alenia Space will be responsible for designing, engineering, and developing the REV-1 vehicle. Likewise, Space Cargo Unlimited will be the owner and commercial operator of the vehicle. Space Cargo Unlimited plans to commercially operate a fleet of uncrewed cargo vehicles capable of returning to Earth to exploit the potential of microgravity for commercial applications on Earth. The REV-1 pressurized vehicle will be a real floating space factory. Furthermore, it will be for specific missions, especially in biotechnology, pharmaceuticals, agriculture, and new materials. REV-1 will be able to create unique laboratory conditions and real clean rooms essential for this type of research and manufacturing. The first REV-1 vehicle, for launch in late 2025, will require adaptation to any available and compatible launcher system. This will make it unique to perform new missions, especially in an equatorial orbit, with a design allowing it to be reusable for 20 missions. The REV-1 will carry payloads for 2 to 3 months in space. Israeli defense tech company Elbit Systems has launched a lethal, autonomous suicide drone. The Lanius is an agile racing quad with a range of AI-powered scouting, mapping and target classification abilities, and the ability to explode when required. The Lanius is designed to travel in groups of 3, sitting on top of a larger, mothership-style drone until they're deployed. Its maximum takeoff weight is 1.25 kilograms, including a lethal or non-lethal payload up to 150 g. A small hobby-style lithium battery gives it a maximum flight time around 7 minutes. On top of a simple, boxy-looking carbon fiber racing drone chassis. The Lanius is fitted with numerous sensors and cameras, as well as an NVIDIA Jetson AI system on module designed specifically for rapid interpretation of fast-flowing data streams with low energy consumption. It links up with Elbit's own Legion X combat swarm management software for multi-drone autonomous missions. Alone or in a swarm, the Lanius is designed to enter an area and begin autonomously mapping it out using its AI capabilities and collision avoidance systems. It'll detect and label points of interest, as well as things like doors and windows, whether closed or open. And it'll enter buildings and search them with or without direction or direct control from a human pilot. The line between crewed and uncrewed aircraft has blurred even more after a Sikorsky Black Hawk helicopter carried out a demonstration cargo mission as well as a medical emergency rescue entirely on its own without anyone aboard or human guidance. The recent demonstration used a standard UH-60A Black Hawk that was retrofitted by Sikorsky and DARPA with DARPA's Aircrew Labor in Cockpit Automation System, Alias, incorporating Sikorsky's Matrix autonomy technology. These turned the Black Hawk into a completely automated aircraft that can take over key pre-flight procedures, including power, secondary control, wind checks, as well as the ability to control elements of adaptive flying like takeoff and landing. In addition, the helicopter can respond appropriately to emergency situations without human supervision. During the demonstrations, the Black Hawk was loaded with a cargo of 400 units of real and simulated human blood weighing 228 kilograms. Two pilots flew the Black Hawk to the starting point, landed, switched on the Matrix system, and exited. Matrix then took complete control of the helicopter and flew 136 kilometers at 185 kilometers per hour while hugging the valley terrain at an altitude of 60 m to avoid detection. The Black Hawk was then fitted with a 12 m sling holding an external load of 1,179 kilograms and took off. About 30 minutes into the flight, the helicopter was ordered to divert to a new location by a ground operator using a secure radio and tablet. Once there, it was commanded to release its load, land and wait while a casualty in the form of a mannequin was loaded aboard on a litter. NASA and DARPA have agreed to develop and test a nuclear rocket engine in space as soon as 2027, using a nuclear reactor as its power source. It would outperform chemical rockets and greatly reduce the time for the first crewed Mars mission. The latest endeavor is the demonstration rocket for Agile Cislunar Operations (DRACO) program, which is tasked with developing a nuclear propulsion system that is capable of sending a mission to Mars and also to provide the U.S. Space Force with a means of getting to the Moon and moving about cislunar space with large payloads at very short notice. By using a nuclear thermal engine to heat a propellant to extremely high temperatures to generate thrust, a rocket could have over 3 times the efficiency of a conventional chemical-fueled one, which would reduce transit times and increase payload potential. For a crewed Mars mission, this would mean less radiation exposure, fewer detrimental effects from weightlessness, and less of a need for supplies or overly robust flight systems. In the new NASA-DARPA partnership, NASA's Space Technology Mission Directorate, STMD, will lead development of the nuclear engine, which will be integrated into the DARPA spacecraft in the form of an upper stage that will only operate in space. Meanwhile, DARPA will continue as the contracting authority for the development of the entire stage, reactor, and the engine in anticipation of a first flight test in 2027 at the earliest, hopefully at a discrete distance from Earth. It may look like a lightsaber sitting on the surface of Mars, but this titanium tube is actually a sample canister dropped off by the Perseverance rover. This could eventually be the first pristine sample of Martian soil and rock returned to Earth in a future mission. Since it landed on the Red Planet in February 2021, Perseverance has been collecting samples of dust, rock and even air, while the rover analyzes many of these itself. Some samples are stashed away in titanium tubes for a future mission called the Mars Sample Return Campaign. This mission, currently still in the planning stages, is expected to involve a series of robots that would run a relay race to get the samples back to Earth. First, Perseverance would hand off the samples it's collected to another robotic lander that would set down nearby. From there, the lander would use a robotic arm to place the samples into a capsule on a small rocket. This would then blast off into orbit around Mars, where yet another spacecraft would grab them and finally bring the samples back to Earth for scientists to study, including looking for signs of microbial life. Well, That was the latest news for today. We hope you like it. Do not forget about likes and subscribe to our channel, it will be even more interesting. So see you in the new releases.